everyone. Thank you for coming. I hope you enjoyed your lunch. I'm Artur. I'm a software engineer at Fresha. Fresha is a platform for wellness and beauty salons that helps them organize their work. It's also combined with a marketplace for booking appointments by their end customers. And we use Elixir heavily, and we went a pretty long road to get independent Elixir microservices. Today, I'm going to propose a solution on how to split an Elixir umbrella application into separate microservices with not so much effort. But first of all, why? What can we gain with this approach? Basically, we can get most of the advantages of microservices. We will end up with independent applications, which might be easier to develop. Also, smaller applications. I mean, shorter compile time. Elixir is quite well optimized for compilation. Like one change doesn't trigger the recompilation of the whole project, but imagine monorepo with a big umbrella and 10 teams creating changes in all the places, and you pull those fresh changes and you just want to run your unit tests, and that takes a lot of time. So these applications may be easier to scale because one app can be more hungry for resources, and with separate runtimes, it's possible to adjust these resources independently so that no app stays hungry. We can also get some perks in local development. If you spread the apps across multiple nodes in the cloud, we can replace one node with an instance of a node running locally. So like kind of take one brick out and put there our local brick. Also, this solution requires less effort than, for example, gRPC with protobuf files, which obviously has its own advantages, but at the cost of more work. So our goal here is to turn a monolithic umbrella app into microservices. First, a quick recap what an umbrella actually is. So umbrella is a way to structure an Elixir project, which consists of sub-applications that are dependencies to each other. Here's a example of a simple umbrella project with Phoenix. So it consists of two sub-apps. One is responsible for web interface, and the other one holds business logic. So it's a simple to-do application. They have one common config, and their mix files contain information about dependencies between them. I will show it in the code so that we are on the same page. I just need to travel in time a little bit. So yeah, here's this application. We have two apps. We have To-Do and To-Do Web. For example, if you check this mix file, we can see that it needs To-Do, which lives in this umbrella.
Can you make it a little bigger?
Good idea. Yeah. So it's a mix file from To-Do Web. And here's the line that defines this dependency. So now to achieve our goal of splitting an umbrella, we need to basically change the things that I have just mentioned, so the parts that are specific to umbrella. So information about dependencies between sub-apps needs to be removed. Each sub-app will have a separate config. So previously we had one config that holds informations for both apps. We need to split them into separate configs with pieces relevant to each of the application. We also need to do a couple of adjustments in mix files because now, for example, config files will have different paths, so we have to reflect that in mix files. And we also need to set up communication between them. This is the most fun part because basically here's a controller from this application that in Umbrella app it invokes a function from the sub app that holds the business logic. Here it returns a list of tasks. But after we split them, this code is no longer available locally, so we can't invoke it just like that. Applications are now separate runtimes, possibly run on different machines. So now the communication needs to be done over the network. So these applications will become separate nodes. And quick recap: what is a node? It's basically an instance of Erlang virtual machine. Nodes can communicate between each other, and basically they together form a distributed system. Here's a simple example how to connect two nodes. So here are two tabs, two terminal tabs with interactive Elixir sessions. It's required that they are given some names. After we connect them, we can see that they appear in their lists of connected nodes when we call node list. And that example was very trivial, very manual. So the question is how can we establish connections between nodes in real life on production? And the answer is libcluster. Libcluster is a really nice library that provides a mechanism for automatically connecting nodes together. That also includes automatic discovery of nodes and healing. So to make it work, all you need to do is to plug in the supervisor provided by this library and choose an appropriate topology option. And topology here is basically a strategy on how to discover and connect nodes. And there are a few topologies that are ready to be used, that are provided by this library. And in this example, I'm using local EPMD, which is very useful for local development. So how it works, it automatically discovers all the nodes on running on a local machine, on local host, and just connects them into a cluster. If a new node appears, it also gets connected. Okay, so we reached to the point where we have two separate runtimes, and our nodes are automatically connected. And since their code is no longer available locally to each other, we need to add some mechanism to allow the communication between them. And again, we have a mechanism that is perfect for this task and is ready out of the box, and that is RPC module from Erlang. And as the name suggests, it allows you to send RPC calls between nodes. And here on the left side, there's a simple terminal example presenting how RPC call function is used. It's called from to-do-web node. It takes arguments, node name, module name, function name, and its arguments. And this code is run on the other application, on the other node, and the result is returned. So here you can see how it's used and what's the structure of the returned data. And on the right side, you can see the change in our example application. So the controller of the web app no longer invokes local function. Now it uses RPC to call the function on the other node. And basically that's all to make it work. So just a few changes and RPC call, and now we have separate applications that talk to each other. However, I think the developer experience could be improved a little bit, and we can add some syntactic sugar to make it look a bit more like the original code. And this can be achieved with the help of macro. What is macro? It's basically a way to do meta-programming in Elixir. So macro is a code that's we can say generates other code at compile time, and more specifically, there's a compilation step where code as text is turned into abstract syntax tree, and this is kind of an intermediate structure, and macros allow us to modify the structure and therefore change how the code works. And here you can see macro remote, which wraps a piece of code, and what happens inside of it is this piece of code is turned into AST. You can see this structure over here in this comment. So this past piece of code is available here as AST, and I'd say it's a semi-human readable structure, but it's perfect for parsing it with just pattern matching. So this code takes relevant bits and prepares arguments for RPC call, and this RPC call is wrapped into quote, because we don't want to call it in macro. during this step. The point is to generate a code that will call RPC in controller. So in short, this code that we have now in the controller is equal to this RPC call in the previous example, in the previous step. This macro can be extended a bit further. Here are added two more things. First one is the ability to pass just a short name for simplicity. RPC call requires a full node name. Here I used node list to fetch all the connected nodes, and then find an appropriate full node based on a past short name. So, for example, now we can just pass to do, and this code will find, for example, to do at localhost, and will use it as a recipient of the RPC call. Another thing that I added here is a basic error handling. So if node is not connected or the call fails, then an error is raised. So we are a little bit more informed of what's going on. Okay, so now I'll present how it works with our example application. Okay, so here we no longer have umbrella application. We have two separate apps. They just stayed in the same directory, but we can see that they don't have any in-umbrella dependencies. Right, and they also have their separate configs. Here, one is here, just typical configs, but now each of them has their own set of files. Yeah. And again, this is how the controller looks like. So it uses remote macro that wraps this piece of code. Other functions, other endpoints do the same for creating tasks, for deleting them, etc. Once again, this is the implementation of the macro. Yeah, and the question is, does it work? Yeah. I'll make it bigger. Little more. Yeah. Okay. Okay, so here I'm starting to-do web application, which is a Phoenix application. So it's starting server. I had to give it a name. And here it's a plain Elixir app. So I had to add no halt option because otherwise it would just execute and be killed. So I needed to work all the time. We can see that it got connected automatically with libcluster to the to-do web application. Okay, and it's working. Can add and delete things. Yeah, definitely working. Let's check what happens if I kill one of those apps, the one with business logic, the plain Elixir one. Okay. Node not found. We got an error raised within the macro. So, but we can see that the Phoenix application is still working, right? Okay, so there's one important topic to cover. How does this solution affects tests? So this transformation makes tests a little bit more troublesome, but I can see a few possible approaches in tests. So the simplest one is to just run all necessary nodes for tests, but that kind of misses the point of the solution. Tests are no longer lightweight. Because we need to run the whole setup, the whole system, basically, just to run tests. But the advantage is that it's very simple. A bit similar approach is to also run nodes that are required by other applications, but with different simplified implementations that are used only in tests. So, for example, we have application with some business logic that has database. Some processes are going on there, but our simplified application could just return hard-coded values. So here the advantage is that it's more lightweight than the previous point, but and it also at least partially allows testing the integration between nodes. But of course, the cost of additional effort of writing those implementations of the nodes. Another possibility, quite interesting, is to remove in-umbrella dependencies that I mentioned before, but leave them for test environments. So, in other words, we would split applications for development, for production environments, but for tests, we would still have an umbrella. So the tests would be the code would be available locally from other sub-applications, basically. So nothing would change for tests. And the last approach is mocking the macro to basically return first save save data in process dictionary and then to fetch it from there. So here is a test of the controller, and before it uses the endpoint that is under test. It puts some hard-coded data under this key in process dictionary, and this macro was a bit changed, and now it works differently in case of test environment. It fetches the data from the process dictionary and returns it. So at the beginning, I told you why is it worth to use this approach. I think it would be also fair to say a couple of words why not. So first of all, we have no isolation between nodes, so there's no limitation, and at least out of the box. And basically, any public function can be from one node can be run on the other node. However, the same is true for Umbrella and its sub-applications. So at least it's not making the things worse. Also, this solution is only possible for Elixir and Erlang. In practice, theoretically, underneath there are certain protocols, so they could be implemented for other languages, but I guess that's probably a ton of work. So it would be probably hard to justify in real life. So if those things are important, then things like gRPC could be a better choice. Also, one could argue that this solution is less explicit. It involves communication over network, but is not so much visible at first glance. On the other hand, that's kind of a point to treat it as a detail that is hidden on purpose. So something debatable. It's also worth saying that this solution pretty much only makes sense if the project has already sensible splits of logic between sub-applications. So if code is a spaghetti, then following this approach will only make it a distributed spaghetti. Yummy. And I also would like to mention a couple of interesting resources. First of all, there's a great blog post by Anton Miszczuk, and this blog post was actually my inspiration for this talk. So I'm very, very thankful for that. Also, my former colleague, Karol Słuszniak, created a really cool gaming platform and wrote an article about it, and its topic is quite relevant to this talk. Here's also a link for the repository of libcluster, if you're interested. And I also posted the example app, and the repo is available here if you want to have a look and at it and get some more details about it. And that's all what I wanted to present for you today. If you'd like to discuss it further, or you have some ideas or comments, then I'm very happy to talk about it. So thank you very much.
I think we have some time for questions.
Hello, thank you. Thank you for your talk. I have a question. So in this example, we had one of each application running on the same machine. What would we do if we want to run, for example, one lightweight web application and 3 replicas of more heavyweight, the business logic on a distributed system on the different machines?
Yeah, so libcluster provides other topologies. That's how it calls it. And here I use pretty much the simplest one that is I think only suitable for development. But there are, for example, topologies that integrate with Kubernetes and yeah, it's quite automatic as far as I know, but haven't tried it. I recommend checking the documentation of the libcluster, and it's basically there are ways to set it up on production for different scenarios.
Okay, thank you.
Thank you. During your call, you shut down one of the nodes, right? What would happen if there was still a call was running still, and one of the nodes got killed, for instance, during a deploy or something like that? Does the RPC module handle that, or do you have to handle that yourself?
Again, could you repeat? When is it killed?
For instance, when you deploy one node, and there was still a call running from the
Call
web.
running. Not sure what happens. Probably it will fail. I guess to make it more robust, you could add some kind of queue. So to gather those calls, and they would be consumed when the node is up. That comes to my mind, but of course it adds to in the infrastructure, and yeah, so we get something at the cost of something.
Okay, thank you. Yeah.